You're here because you want to master isomerism in organic chemistry with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. Let's talk about a new concept in organic chemistry called isomerism. In isomerism, isomers are molecules with the same molecular formula but different structural formula. In other words, you can have molecules with the same ratio of carbons and hydrogens and all these atoms, but you can also have different structures in organic chemistry. Typically in isomerism, there are 3 kinds of isomers. There's chain isomers, position isomers, and functional group isomers, with their definitions below. Chain isomers have a different number of carbons in the main chain, so there could be branching involved. Next, you have positional isomers, where there are different positions of the same functional group. For example, a methyl group could either be in the 2nd or the 3rd position. Next, your functional group isomers. They are where your functional group totally change. Now, below are the following steps for drawing your isomers. You can memorize them. It's not necessary to reproduce these exact steps in writing like this, like step 1, draw the straight chain version, step 2, think about shifting. You don't need to memorize this, but it would really help if you knew this because it would frame your mindset of thinking what are the potential isomers. With this, you wouldn't be able to miss out on any single isomer when you are drawing them. So step 1, you want to draw the straight chain of the isomer first, the most basic version. Then you want to think about shifting the functional groups first. This is called positional isomerism. Once you do that, you keep doing it until you keep producing structures that are the same. I'll teach you how to look out for that later. Then you want to think about branching afterwards. So you will manipulate and maybe reduce by 1 for the carbon chain. Let's say you had a 5 carbon chain long main chain. You're going to reduce it to 4 and make it so that one of the carbons actually forms a branch in the middle. You will also think about shifting the functional group again. So you see there's kind of a pattern over here. For every length of a carbon chain, you want to shift the functional group, then change the length of the carbon chain, then shift the functional group, then you repeat and repeat and repeat. Afterwards, you will restart back at step 1. Why? Because you have to think about new major functional groups, and then you start with the longest chain first, and then you repeat the steps as well. So you do this for every single new functional group for the same molecular formula that you can think of. So here's a typical example. Let's say a question asks you to draw all the isomers of the organic compound with a molecular formula of C4H8. Or sometimes they will ask you to count the number of isomers. Very typical question in MCQ. But in order to know, you have to draw everything out first. So let's go step by step. Well, with prior knowledge, I know C4H8 follows the general formula of CnH2n. A typical functional group that follows this general formula is alkenes. Alkenes with 1 double bond will fulfill this general formula. So let's start with the longest chain first. And there's a double bond over here. And for good practice, we can name these compounds. Naming will tell us whether the structures we draw are the same. For example, this is but-1-ene because there's 4 carbons in the main chain and there's alkene group, so it's an ene and it's in the first carbon because we want to give it the lowest number possible. 1, 2, 3, 4. Let's move on to the next one. Let's try to shift the position of the functional group. In this case, it is as such. If I shift the functional group to the 2nd position, you'll get an entirely different compound. And this is actually but-2-ene. Because if you do it the count, 1, 2, 3, 4. Now if you were to shift the functional group again, this is what you'll get. You will get this. And you have to ask yourself, how do I name this? Is this called but-3-ene? Well, no, because if I were to count these carbons normally, This is actually 1, 2, 3, 4. So this is actually another version of build one in. So don't fall for this common mistake that students typically make. In isomerism, you need to make sure that you don't draw the same compounds. So this is actually not an isomer. Well, technically it is, but we've already drawn it, so you don't want to double count them. We then follow up by changing the branching or changing the length of the main carbon chain. Now instead of 4 carbons in the main chain, I'm going to move one of the carbons as a branch. So I have 3 carbons now. And as a branch, it has to be put in the middle. It can't be put at the ends because it will not be a branch otherwise. So this will form a methyl group. And if I were to fill up the rest of the hydrogens, this will be propene. And there's a methyl group in the center. This is 2-methyl propene. So this is another one. Can we shift the position of the functional group? Again, if we do this, you will still get the same 2-methyl propene. So that's actually it. You can not do any more branching, because if you do this, you have 3 carbons, you reduce it to 2 carbons. You can't put a carbon in between 2 carbons. There's no branch. With this said, we have to think about any other functional groups. So are there any other? Well, in the typical CnH2n general formula, there is another way and another functional group that you can achieve. That would be your cycloalkanes. So if you form carbons in a cycle and you fill up the remaining hydrogens with 4 carbons in this main chain, this is called cyclobutane. So this is considered another functional group. And can you do branching? Yes, you can. You can actually put 3 carbons in a cycle and have one of the carbons in a branch. And if you fill the rest of the hydrogens up, you realize this still fulfills the same molecular formula. This is actually methyl cyclopropane. I don't need to put a number for this methyl because it doesn't matter which carbon it's on. It will always be 1-methyl cyclopropane. So in this case, the 1 can be negated. So for isomerism, be sure to follow the steps that I listed before, and with enough practice, these steps should come naturally when you're thinking about which isomers to draw, or how many isomers are there with a particular molecular formula. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.